Hi. So I promised you a little review of Pythagorean theorem. So let's do that. I want to go back to the paper that I was using before in the last video. Let's see how do we do that. Here. And there we go. All right, so in this last problem that we just did, example 3, there's a right triangle here. And that right triangle, it's actually two right triangles. They're both identical. They're just flipped over from one another. Has a right angle, the hypotenuse, which is the longest side, the side opposite the right angle, and two other sides. So that right triangle looks like this. And it's got a 5 here, and a 12 here, and a 13 here. And they actually gave us all of those side links in the picture above. They gave all those to you. But they won't always. So it's true that 5 is one of the legs. This is called a leg. And this is also called a leg. Those are the sides next to the right angle. And this is called the hypotenuse. And Pythagorean theorem, which we proved in class at one point, says that if you take one leg and you square it, and you add the square of the other leg to it, you will get the square of the hypotenuse. So 5 squared is 25, 12 squared is 144, and 13 squared is 169. All squares that you should know, even though 13, that's a very, very important one to know. And when you add these two together, 25 and 144, you do in fact get 169. So there, Pythagorean theorem is actually true in that scenario. Let's try another one quickly. Let's say we had, this will not work out beautifully. Let's say we have, I don't know, 7 and 4. And we want to know what the hypotenuse is. We'll call that h. So we would take the two legs squared, just like we did here, and make them equal to h squared. So 4 squared plus 7 squared equals h squared. 4 squared is 16. 7 squared is 49. H squared is h squared. It's actually the sum of 16 and 49. So 16 plus 49 seems like 65. 65 equals h squared. That means h is approximately 8 point something. I'll call it 8.1, but it's, it's a little bit bigger than 8 because 64, the square root of 64 would be 8, right? And therefore, if we put an 8 in here, 8 squared would be 64. We just have to have a little bit more than that. So that's an example where h is the unknown, and our unknown goes on the other side of the equal sign. Let's do one more where the unknown, instead of being the hypotenuse, let's do one where the unknown is one of the legs. It doesn't matter which leg. Does not matter which leg. So let's take a leg here and a leg here, hypotenuse here. Let's say the hypotenuse is, I don't know, 10. And let's say one of the legs is I don't know, 7. And that leaves this to be our unknown. Oh, we gotta see that a little bit better, huh? Okay. Yeah, the old problem's still there a little bit. So we're gonna take x squared plus 7 squared, which is 49. 7 squared equals 49. Equals 10 squared, or 100. We're going to subtract 49 from 100. We're going to get x squared equals, this is going to be 100 minus 49. It's going to be 51. And therefore, x has to be equal to a little bit bigger than something close to 51. So I'm again using this. This is almost equal to, let's say this is 7.1 or about 7.1. All right. We're going to deal with things like the square root of 51 next year. Next year. I'm not going to deal with that now. Okay. But there's a little Pythagorean theorem review, update, quick lesson, whatever you'd like to call it. And I hope that helps.